Hello, my name is Matthew Hine. I'm the Chief Product Officer at RDXWorks, and I'm here to talk about resources. Resources are the way that tokens are created on the Radix network. Any kind of token you can imagine, everything from a simple crypto token to an NFT to all sorts of complex assets. They're all created as what we call resources. So today what I want to do is actually show you a little bit of a demo of what we really mean by resources, what it means for user experience, and what it means for you as a developer who wants to issue various kinds of assets. I want to show you just how easy it is to create a resource. In fact, you can create resources without any smart contract code at all on Radix. And then on top of that, show you what sort of flexibility you have. We don't have sort of a fixed library of certain kinds of tokens that you can create. What we really have is universal asset behavior that you can configure without smart contract code, but you can still link those assets to business logic, whether decentralized logic or off ledger logic, however you want. So I'm going to go through a demo of how this works with the wallet, how it works with resource creation to give you a real tangible idea of how powerful resources are on Radix. Okay. So what I'll start with is just the very simple experience of what a resource is. As I said, it can be anything at all. And the Radix wallet is able to present resources in a really nice, intuitive way because they're all universal things. They're not smart contracts that you have to sort of tell the wallet about. They're all really in your account. So I can switch over to a view of my Radix wallet here. And you can see that in this particular account that I've got here, I've got a bunch of different accounts. But I've got an account here that has a couple of different fungible tokens in it. These are creator resources. So XRD, for example, I can tap this and you can get an idea of, there's a description there, you can get address, current supply, also behavior. We'll talk about behavior quite a bit here, but this gives you a very direct, reliable idea of what that token is allowed to do. I've also got just for the sake of demo, I've created a demo USD token. We're going to see that use that a little bit later. I've also got a bond manager NFT. I'll tell you what that is, but this is a badge. This is an NFT that's going to be used for authorization, and you can have a variety of different kinds of assets. So the simplest possible thing is if I want to just send an asset to somebody else, I'll show you what that looks like. So in my account here, I can go to transfer. And I can choose an account to send that resource to. I'm going to choose a different wallet. So I've actually got a second phone here set up. This is my primary phone. I've got another one. So I can link this one, or I can get that address from that other's QR code. I'm going to use that as my recipient address. And we'll pick some XRD. I'll send that over. I'll just send maybe 10 XRD tokens to that account. So here you can see, you've probably seen in maybe other demo videos we've got, you can see the presentation of our transaction manifest here. So for us, we can describe all sorts of interesting asset movements and transactions very flexibly. So if I'm sending tokens, what that means on Radix isn't a call to a smart contract. It's literally withdrawing 10 XRD from my account and depositing 10 XRD to the account that I want to be my destination. It's much more like physically moving things around in the real world, which is really the pattern we try to follow. If you imagine giving 10 bucks to somebody, it would be me getting my wallet out of my pocket, pulling 10 bucks out of it because I'm allowed to do that, and then giving those 10 bucks to somebody else. That's basically what we're doing here in our transaction manifest. So I am authorized to withdraw by the signature from my account, and I can deposit that to somebody else. So I'm going to go ahead and slide to sign that transaction. And there we go. So I've just sent 10 XRD to that other account. So real simple. Again, this is all using native features of the Radix network, building transactions, withdrawing from accounts. All these things are native Radix features. There's no special smart contract code. There's no ERC20 contract that we had to call and we had to trust an interface on. Much more direct. And this applies to our smart contract development model well if you want to manipulate resources. But let's set that aside. So this is the basics, but to give you an idea of what this really means to create a resource and to use some of the more advanced features, we've built a couple of pretty simple little demo dApps that I want to use here. So at this point, I'm going to drag my wallet over to the side here, and I'm going to pull up my browser window. So here we've got a couple of different tools that I'm going to use here. One of them is the Radix Developer Console. So this is a simple DApp that we've built to do kind of common things you might want to do as a developer, including create simple tokens. It's not a fancy front end, but it'll do some basic things pretty nicely. And what I'm going to do as part of this is I'm going to create a very, very simplified form of a bond, a real world asset. So imagine we wanted to tokenize a bond, and then we wanted to apply some controls to where that bond can go, who can use it, who can manage it, all those sorts of things. Kind of a traditional finance use case, you might say. So we can do all of that without smart contract code. In fact, everything I'm going to demo here doesn't use any smart contract code. I'm not going to be deploying an ERC20 contract. I'm not going to be making any smart contract calls. This is all just interacting with resources that we can request from the Radix network and configure how we want. Now, of course, you can write smart contract logic in Scripto, which allows you to manipulate these resources. But at a simple level, we can do without it because it's so easy to do on Radix. Okay. So the first thing I'm going to do is create my bond resource. So I'm going to go to the developers tool. We've got something called create token here. And the first thing I need to use this is to connect my Radix wallet. So I'm going to go to connect. I've already linked my phone to my browser, so I immediately get that request over Radix Connect. I've got a little demo persona here I'm going to use to log in with. And there we go. So I've already set up a couple of accounts that I'm sharing with the developer console because I've previously logged in with that persona. And we've got this little UI to do some things. So let's set up our bond asset. We're going to create a token. Now this whole UI is really just setting up what it allows me to do is to set the parameters on a resource. And then ultimately it's just going to build a transaction to submit to the Radix network to request that the network create that resource for me. That's how you create a resource. You can do this in scripted code, or you can just do it directly in a transaction. So in this case, I'm going to, I need to choose where I want the supply of that to be. So I'm going to choose I've got a demo manager account that I'm going to use to create my bond. And I choose what kind of token I want. So I have to choose if it's a fungible or a non-fungible token. I'm going to make this a non-fungible. Track supply, that's fine. I need to pick a name here. So I'm going to call that my new bond resource. Now this is the metadata on the resource name. So if you're building a non-fungible, there's sort of a top-level definition of all of the tokens, all of the non-fungibles in that supply. And then you can have individual non-fungibles, the actual things that you send around, which can have kind of their own data. You'll see that in a moment. If I wanted to, I could set an icon URL. I could set a description here. So I could say, you know, this is a bond resource for my demo. I could also make some tags here if I wanted. So maybe I wanted to call this, you know, TradFi, something like that. I can tag my resource. These are all things that are recognized over the Radix wallet. An info URL if I wanted to do. But those are some simple things. You can actually specify arbitrary metadata, but we're not showing that in our simple UI here. We're just kind of setting up kind of the standard fields. Now, the auth roles is a really important aspect of this. This is now configuring what I like to explain as the behavior of the token. Now, in our case, as I said, we don't have kind of like a fixed list of like, well, this is an ERC20 or this is an ERC 721 or all these different types that have very particular definitions. What we did when designing resources was think about the fact that actually, if you think about assets in the real world, they actually have quite a bit of similarity. There's kind of some core rules of anything that you would choose to call an asset. An asset is something that at any given time, one person has the asset and then they can give that asset to someone else. So there's this notion of transferring it from one person to another. We would want to have some rules about who can create the asset, who can destroy the asset, who maybe there's sort of a manager of the asset that has certain powers of being able to pull it back from somebody else if there's a reason, or freeze it in place. There are some things like this. Now, all of those different options depend on what kind of asset you're talking about. So you might have many assets where you say, like, look, nobody should have the power of recalling this or freezing it. It's just a simple thing that one person can own, but maybe no one can create or destroy it. Like, all these different combinations are fundamental to the definition of an asset. And so what we've done with resources on the Radix network, this is guaranteed by the Radix engine, our virtual machine, is specifying these very particular, what we call state changes of creating, destroying, freezing, recalling. These are all the fundamental things that resource can do. And then what we can do is we can choose who has the ability of doing those things. And that's actually quite powerful, because what it means is that we can either lock those things off if no one should be able to do it, or we can give the power to do these things only to certain people by giving them a badge, and that badge is something they need to present to be able to do that thing. Or we could give that badge to smart contract logic. So for example, you might have a smart contract or a component on the Radix network that says, well, this component defines all the business logic, whether it's, for a game asset or for a TradFi asset or whatever it is. That smart contract logic holds the badge, which gives it the ability to make decisions about how that thing can move around, how it can be destroyed, how it can be created, all these sorts of fundamental things. And what we found as we went through lots and lots of use cases of different kinds of assets is that really we can express just about any kind of asset that people come up with in these terms, basically modeling it on what can this do, who can do those things, and what sort of logic needs to have that control. We like to say that we separate the asset from the business logic. So on Ethereum, for example, or most smart contract networks, if you wanted to have a game NFT, you would build the game logic into the NFT smart contract. That's actually quite constraining, and it means that the wallet doesn't really understand it. You need to have special support. There are a lot of shortcomings in that model. It also means the wallet really, you as an outsider can't really say for sure what the behavior of that asset is, because it's all built into this black box smart contract logic. In our case, all these behaviors are specified to the network and enforced natively, and all of your business logic can be separate, and it basically just has control of these things. So let's go through them one by one to make this tangible. I'm talking too much. So what we do is this little dashboard lets me set up those different behaviors and who can do them. So the first thing that we specify is the owner role. There's a single owner that we can define that basically can be used in the other things. It's kind of like the top level admin for the resource. If you want one, you can specify none. If you say no one should be an admin for this, this should be decentralized. But in our case, for this bond, we want to say, well, we're gonna say we want a badge, a particular badge to the owner. Now, if you dig in beneath the surface, you can actually set up all sorts of like multi-sig rules and stuff if you want to, but we're just going to use a single badge here. And then we're going to say, we're going to want to pick what we want that badge resources to be. And as we said, in my wallet here, I've already got this bond manager resource that I've already created before. So I'm going to use that. I'm going to say that bond manager is the owner badge for this new resource that I'm creating. And I can also specify a particular one. I could say like this particular non-fungible, or I can see anything, any bond manager. I'm just going to stick with that. Owner role updatable. So I'm going to say, do I have the ability of updating that role? I can say, sure, as the owner, I want to be able to update who can do that. Now we get down to some of the more core behaviors. So minting, who can create this token? Who can create new bonds? In this case, I want to say, well, only the owner can create new bonds. I've got a system which has its own logic, which decides when we're going to issue a new bond to someone. Again, that could be off-ledger logic, or it could be crypto logic that can do that if we give it the badge. Then we also say who can update the fact that it is who can update the thing, or who can mint. So who basically can choose after the fact to say, well, I'm actually going to change who the minter can be. So I can make that deny all. I'm just going to make it owner for simplicity. Same thing with burner. I'll just make that owner and owner. I can burn, and I can choose who can burn. Freezing, maybe for my bond, I want to be able to freeze. I want to be able to say, well, these things are transacting around, but maybe there's some reason I need to be able to say, hey, no more transfers until something gets audited or whatever that is. In this case, maybe I'll make that one deny all. I say no one can freeze this. It's a liquid bond. Once it's out there, there's no way of me globally freezing all of them. I'll just go ahead and leave that deny all. Recaller. So maybe me as the issuer of the bond, maybe my logic needs to be able to recall that bond back for someone to basically say, well, that bond has now been paid off or canceled or whatever it is by our financial logic. So I'm going to reserve that for the owner here. I'll also make this owner. Withdrawer. So basically this means, as you saw when I did the XRD transfer, a transfer means withdrawing it from one place and depositing it somewhere else. So this basically says who is able to move it from the place where it is, from where that bond resides. In this case, I'm actually going to say, you know what? Only the owner. The owner needs to be able to approve of any transfer. Maybe there's restrictions on who can hold that bond. And so I've got logic as the owner that I can enforce here. So again, I can hand this over to smart contract logic that would maybe provide approvals to be able to a proof of that badge that would allow people to move it around from place to place. So I'll leave that as owner and this owner, but deposit, I'll leave that as all. Like basically once you've withdrawn it for some place, you can deposit where you want it after that point. So I'll just make that allow all. I'll say the owner can change that. Metadata, sure, owner, who can change the metadata on this, and then non-fungible data, who can change all that stuff. So I'll just leave that as owner. This is all fine. So those are the top level resource behaviors. And again, all of those things really kind of define what we call it is this goes into what we call a finite state machine. So any given resource, it has this very platform level set of rules about, a given resource can only be created, moved, destroyed, recalled, frozen, all these things. And we can set up who can do all those things. And this becomes very, very flexible. So once we've defined all those things, I'm going to create an initial supply of that token. So I'm actually going to create some bond NFTs as part of this overall resource. So I'll create maybe, let's call this demo bond 1, and I'll create a demo bond 2, properly capitalize it, and demo bond 3. So I'm going to issue 3 bonds, but of course, because I have the minting ability, I could come back and issue more bonds in the future if I wanted to. I'll leave the other description kind of stuff blank for simplicity's sake. Okay, so now I've set all this up, and what our developer console do is it's just going to build a transaction manifest, which it's going to send to my wallet, which was going to do the things I just talked about here. It's going to basically issue a set of commands to the Radix network to say, I want a resource that's configured like this. I want these non-fungibles, and then put those non-fungibles into my account. So let me send that to my wallet. And here I can see it. So it's creating these 3 different non-fungibles, which are going to be deposited to my account. If we wanted to, we could go up to this advanced mode here and see the raw transaction manifest. So here you could really see the exact calls we're making, which is doing all the configuration of this resource. We probably will provide a more friendly summary of this, but for most users, you're not doing a lot of resource creation. This is mostly a developer thing, so we don't summarize that part of it. Okay, so let me sign this transaction. And there we go. So now if I go to my NFTs, I can see I now have my new bond resource. And if I go into there, I can see that I've got those 3 non-fungibles, those 3 bonds that I just issued. That was it. We just created a brand new resource on the Radix network. No smart contract code deployment, very cheap transaction to the network. This is something that you can very, very easily do, even with all of this flexibility that we configured into it. And really, if all you have is a fairly simple resource where those different roles and those different behaviors are something where, well, I just need a badge that, one person can hold and we've got an admin, you really don't need to do any smart contract development at all. The only time when you would need to build smart contract code in Scripto is if you wanted to write decentralized, trustless logic, which could then manipulate the asset and hold the badges to do those sorts of things. But for this bond, I'm just going to keep it simple and we're not going to do any of that. So what are we going to do with this now? Now that we've got our bond resource, let's kind of go through some use cases of what you might want to do with this. To do that, I've created another little app here. I didn't create it. Someone on my team created it. I shouldn't take credit. Alex Stella, one of our devs, built this. It's really cool. So he put together this really simple dApp front end in a very short period of time just to do this little demo. So it's a simple front end, which is set up to be able to send bonds, distribute dividends to bondholders, and recall bonds. All this stuff, again, is just basically building different transaction manifests to manipulate these different things. And I'll show you how it works. So first thing we're going to do, actually, before I move on, let me grab my resource address here because I'm going to need that. So this is the resource address of that bond that we created. In fact, we can click this and we can see on the dashboard, we can see some stuff here. In fact, this is kind of cool. You can see the behavior here. So I can see a third party can remove this asset. Movement of this asset can be restricted. And I can do the same thing in my wallet. If I go here and tap this, you'll see this same set of behaviors here. This tells me very directly a lot of information about what is possible with this resource. It's not just a black box smart contract. It's actually something where the network itself can say, look, I can promise you these things are possible or not possible because it's directly configured and enforced by the network. This is really, really powerful to giving users a clear understanding of what it is that they actually own. You can't sort of rug pull someone by saying, well, secretly someone can recall this from your account. It's like, no. If you need to be able to recall it, you're going to have to put that in the behaviors, and the user is going to know this is a recallable resource. So very, very transparency is the name of the game here. So let me write down my resource address before I forget. Cool. All right, so let me go over to my little bond manager dashboard here. So first thing I want to do is send the bond. Now, actually, before I do that, let me try something that I know is going to fail. Imagine it. Well, no, let me do this the other way. I'm sorry. So let me send that bond. Now, again, as I said, I've configured so that the owner has to approve to be able to withdraw this, to be able to send it to somebody else. So because of that, we've created this little send bond feature that enables us to do that. And I'll show you what that means. It's quite cool. So let me, once again, log into our little dashboard here, pick my demo persona, got my accounts here that I've created. And so let me say, I want to send from my manager account. I want to send, let's say, demo bond 1, and I'm going to present my bond manager badge so that I can send it to this other account. And in fact, let me go up here and I'm going to copy the address. I've got this little user account that I've created in my wallet. I'm going to use that as my recipient. Okay. Now, what does this present means? You're going to see this in the wallet, but basically our whole auth model on Radix is built around this idea of badges. The idea that whether you're interacting with a resource or a smart contract component or anything, you can specify certain badges that are required to be present. You need proof that you have that badge in order to be able to do that thing. So this becomes a very intuitive and flexible way of defining auth. And it's based around resources themselves. As you saw, I have a bond manager NFT that I can use to authorize. Also, signatures in our model just become sort of ephemeral badges. So every time I sign a transaction, it basically becomes a temporary badge, which is used to authorize usually to my account. So we can set this up. So this little what this UI is doing is basically going, I can pick a badge to present a proof of in this transaction, and that's going to enable me to withdraw this bond asset so that I can send it to somebody else. So if I send this to my wallet, you will see that transaction. So I put a little message on it that says sending bond, and this is going to be withdrawing from one account and depositing to another. And at the bottom here, the wallet can see, in this transaction, I'm going to be presenting a proof of that bond manager NFT. This is all in the transaction manifest, and so the wallet can clearly show this to the user that they are providing that proof. So I'm going to sign that transaction. And now if I go over to my user account here, you can see that I've got this bond resource that's been sent to me. That all worked. Let me do one more send here. I'm going to go back into my manager account here. Let me send this to a different account. So I'm going to send this to, I've got my other phone here, which also has the Radix wallet. I'm going to send it to them so I can show you something else. So I'm going to send it to this account. Let's see. So send from manager. I'm going to send demo bond to, I'm going to show my badge. I'm going to send it to this account. I think that's correct. Yep, that's the one. I'll send this one. So same transaction here. I'll just sign this real quick. Cool. So now I've got that in my other phone. You'll see that in a minute. Let me do one other thing here to show you. So imagine I'm not the bond manager. Let's say I'm just a recipient of one of these bonds. I'm just a bond holder. So let me go into my user account here. So this account has no owner badge in it. It just has the bond. And let's say you go, you know what? I'm going to try to send this bond to somebody else. And maybe I didn't notice the fact that I needed permission from this system, that I kind of had to go through their portal or whatever it is. I just tried to send it directly. So I'm going to try to just transfer, just like I did the XRD on the wallet. Say, okay, I'm going to send this to some account. So once again, let me scan this other phone's QR code. And let me try to send that bond asset. There we go. So I'm going to send from my account to this third-party account, demo bond. Now you can see now this time I immediately got an error in the wallet. It says a proposed transaction could not be processed. The reason for that is that a simulation of the transaction just got run. The wallet basically goes, okay, I've got a proposed transaction where I'm going to withdraw this from one place, put it somewhere else. And it ran a simulation of that transaction and it ran into a problem. It realized, hey, this isn't going to be valid. I can't submit this to the network because I cannot withdraw that bond without the proper proof. Therefore, the transaction fails. So the wallet doesn't even try to submit it. It knows up front that this isn't going to work. I'm just going to notify you right away that this is an invalid transaction. So basically what this is, the Radix engine itself providing these really strong guarantees that you cannot send this thing if the owner doesn't approve of it, because that's how the bond has been configured. So there's that. Now let's see, what do we want to do next? Right, let's do a dividends distribution. So now we've got my little demo user account has the bond. I've also got my other phone here, which also has a bond. Let me try distributing some dividends. So let's say we just want to like give some tokens to anybody that holds that bond at this particular point in time. Well, this is actually quite easy to do. What we can do is, first of all, I'm going to select the account that I want to do the distribution from. So once again, I'm going to pick my manager account. I'm going to choose the resource address. So basically, I'm just telling it what is the address of the bond that I want to distribute to. So here's our bond address. And you can see this populated down here. I'll tell you what that means. I'm going to select the token to distribute. So let's say I want to hand out some of that demo USD token that I'd created. And let's say I want to send out, 100 total of demo USD to holders. And down here, we're seeing that these are the two different individuals. So these are kind of the serial numbers on those NFTs. We've got 0 and 1 here, which are the individual non-fungibles for those bonds. You're not seeing the third one because it's held in the manager's account. So we're not going to distribute to the manager. These are the ones held in the other accounts. What's happening here is this web front end is just asking the Radix network gateway. It's saying, hey, for this resource address, tell me who holds those things right now. And the gateway came back and said, okay, I can see that these accounts currently hold that NFT. And so this allows our little web front to say, great, I'm going to show this to the user here, and I'm going to choose who I want to distribute dividends to. I think I've got both of them selected. And I can now, this web front end can now build a transaction manifest to do those distributions in one transaction. And it's just going to be literally withdrawing 100 USD tokens from my account and then depositing 50 to one account and 50 to the other account because I know that's where those bonds are. So I'll do that distribution. And here you can see exactly that. So 100 coming out of my account and 50 being deposited to those other accounts. And I don't need any sort of, I don't need to present any proof from this because all I'm doing is sending these USD tokens around, which don't require any authorization. You can just send them. So I'll go ahead and do that. And that's it. So now if I have my user account here, I can see that, actually if I go over my tokens, I can see that I now have those 50 DUSD tokens. Nice and easy. Okay. Last thing I want to show is recalling a bond. So there are certain classes of assets where basically the issuer of this needs to be able to pull it back. There may be some financial reasons why you do this, or this might even be something like, game logic. Imagine you have a Web3 where your game logic needs to be able to say like, okay, in the game, you just lost a fight. And so you lost a tokenized asset. You had an epic sword, but you lost the fight, which means someone else gets the epic sword. So the game logic needs to be able to reach into your account, grab that game NFT, and then put it into someone else's account. So there are a variety of reasons why you might want logic that allows that kind of recallability, which we set on this resource. So we've got a simple web UI to do that. So I'm going to say, I'm going to recall to the manager's account. I'm once again going to enter my resource address. Once again, I can see that here are where those things are. So I could choose which ones do I want to recall. So I'm going to say, well, maybe I don't want to recall both of them. I'm just going to recall just that one. And then I'm going to select my bond manager badge once again, and then send that to the wallet. So this one's kind of an unusual transaction. We're not getting the friendly preview on this one because recalling is like very much a developer feature. This is not something that generally a user is going to be doing a lot of like recalling of assets from places. Typically, this is going to be like back-end logic running on a server someplace that's going to be following certain business rules, or it might be smart contract logic, which is following certain business rules and recalling things and manipulating them. We can push them through the wallet, but the wallet isn't going to give you a friendly preview of this, at least not today. Maybe in the future, we'll add that preview just on the off chance that a user might want to look at something like this. So nonetheless, I'm going to sign that transaction. And there we go. So now if I go into my manager account, I can see that I now have those bonds back. I've recalled them. So That's pretty much it. Hopefully you can get an idea. Now, again, this is like really basic stuff. Like this is a demo that we kind of knocked together in an afternoon. This is just kind of using, native features of the Radix network. You can obviously do much more complicated things like this. You can set the roles on resources to be held by multiple parties or complex logic, off-ledger systems, your own dApps that are running decentralized on the ledger for fully trustless systems. There's a lot of power in here to build whatever kind of assets, whether it's real-world assets, whether it's sort of crypto native Web3 assets. All of these things are really, really easy to do on the Radix network. You're guaranteed of a nice user experience in the wallet. Your users are always going to get a very clear idea of transparently what is possible with those resources, and they can see how things are moving around. We think that this is one of the really powerful aspects of Radix. And we hope to see a lot of people issuing really interesting Radix assets on the Radix network, simply because it's so easy and predictable and secure and really built into how the platform operates. It's not sort of done at a smart contract level. It's done as a native feature of the network, which is where we really believe it belongs. And if you're a developer, you're going to see that this model really makes your life much easier when you are building smart contract code. You're no longer going to be sort of making calls to ERC20 contracts and verifying that things happen. You're just going to be able to manipulate assets in terms of take and put, very intuitive ways of manipulating these assets. So really excited to talk about this. Hopefully this demo gave you at least a rough idea of the simplest form of all this stuff. And we'd love to see you in our community playing with this stuff.